Hi, I will introduce our paper, BatchFormer, Learning to Explore Sample Relationships for Robust Representation Learning. Despite the great success of deep neural networks for representation learning, it heavily relies on collecting large-scale training data samples, which turns out to be non-trivial in real-world applications. Therefore, how to form robust deep representation learning under the data scarcity by exploring the sample relationships has received a lot of attention from the community, especially for the tasks without good training data to guarantee the generalization, such as long-tailed recognition, zero-shot learning, and domain generalization. As illustrated in the figure, similar classes tend to share similar parts and transferable augmentation. Therefore, transferring shared knowledge from head-seen classes to tail-unseen classes can facilitate long-tailed zero-shot learning. In addition, exploring the invariant features between images belonging to the same class is also helpful for robust representation learning with a few samples. Inspired by this, we propose to enable deep neural networks themselves with the ability to learn the sample relationships from each mini-batch. Specifically, we introduce a batch transformer module or BatchFormer, which is then applied into the batch dimension of each mini-batch to implicitly explore sample relationships during training. BatchFormer is a unified, flexible, and powerful way to explore the sample relationships for robust representation learning. Here is the main framework of representation learning with the proposed BatchFormer. Specifically, we apply a BatchFormer module between the feature extractor and the classifier layer to explore the sample's relationships. Furthermore, with a shared classifier before and after the BatchFormer during training for batch invariant learning, we can then remove BatchFormer during testing. To better understand how the proposed BatchFormer helps representation learning by exploring sample relationships, we also provide an intuitive explanation from the perspective of gradient propagation for optimization. Intuitively, without BatchFormer, all losses only propagate gradients on the corresponding samples and categories, that is, one-to-one, while there are gradients on other samples with BatchFormer. From this perspective, BatchFormer has implicitly augmented N1 virtual samples for each label via the relationship modeling among samples in the mini-batch. We have demonstrated the effectiveness of BatchFormer on over 10 datasets. The proposed BatchFormer consistently improved the state-of-the-art on Cipher 100 LT, ImageNet LT, Innaturalist 2018, Places LT. BatchFormer consistently improves the CGE on compositional zero-shot learning. Besides, BatchFormer also considerably improves the domain generalization baselines. Particularly, we find BatchFormer can also improve the contrastive learning. We observe consistent improvement on Mach-O v2 and Mach-O v3. Meanwhile, we find the convergence of BatchFormer is better than the baseline. We also provide the ablation study on the gradients propagation. We find the rarer the class is, the larger the gradients of the class have on other images in the mini-batch. Thus, BatchFormer actually utilizes the other images to facilitate low-shot recognition via increasing gradients of few-shot labels on other images. We meanwhile find the batch size has a little effect on the performance. According to the visualized comparison, BatchFormer tends to focus on the details and also find invariant representations. Let's conclude our paper. We propose to enable deep neural networks themselves with the ability to explore the sample relationships from each mini-batch. Specifically, we regard each image in the mini-batch as a node of a sequence, and then build a transformer encoder network among the images to mine the relationships among the images in the mini-batch. A more general work, termed as BatchFormer2, can be found in this link. Thanks. If you have any questions, feel free to contact Shiho.